Chapter 9, woohoo! But it's just the beginning of your journey with calculus. And at the end, she realized that the calculus had been within her the whole time. Okay, I'm sorry. I'm a little bit giddy and excited because we're going to be done with chapter 9 and we can move on to bigger and more exciting things like chapter 10, which is going to be super fun. 9.9 is the application section, otherwise known as the word problems that correspond with this beginning introduction to calculus. These are going to be business applications, and to be honest, these are concepts we've been kind of circling this whole time. Even before we started calculus, we were starting to talk about marginal cost and marginal revenue and marginal profit. So partly what I'm going to do is I'm going to go through and we're going to talk about some basic concepts. But you should also know that I'm not going to tell you how to do all of the word problems. The word problems in this section are designed to be similar to what I'm talking about here, but not exactly the same. However, I believe in my heart I'm giving you everything you need to know to be able to do your homework. If that is incorrect and you're like, no, none of this makes sense, please reach out to tutors, reach out to me, talk to me. We can figure it all out. It's the goal is not for you to be frustrated or confused. The goal is for you to be able to take calculus and actually use it to do something. So let us get started with that. Marginal cost, marginal analysis. It's very exciting. So if C, I copied this from the book, this is the way they like to phrase it, if C equals C of X is the total cost function. Total cost is very important. The fact that it's total cost means it's the cost for all of the units, not just the particular unit. So in other words, I'll make a note. For example, C of 5 is the cost, pardon me, to produce the first 5 units. So this includes 1, 2, 3, and 4. So it's total up to that point. So the problem is C of 5 does not tell you what the cost of the 5th one is. It tells you the cost of the whole group of them, if that makes sense. So that's why we refer to this as total cost function. It also combines the fixed costs with the variable costs. So there's a lot going on in this. So if this is the total cost function for a commodity, then its derivative, C prime of X, is the marginal cost function. And then I give an example. Okay, so let's let C of X be this function, 300 plus 12X plus 3X squared. It's going to give the total cost of producing X units, all X units, not just the Xth unit, in dollars. Then, and then here, we have talked about this before. This has come up, but this is marginal cost. Write this over here, marginal cost is the derivative, which is, and take a look and make sure I wrote this out correctly, if cost is 300 plus 12x plus 3x squared, then the first derivative, 300, what happens? Goes to 0. 12x, the derivative of 12x is 12, and the derivative of 3x squared, the 2 comes down, so we get 6x to the first power. Okay, so that's our derivative. So what the heck does marginal cost, why is it useful? Well, much like marginal profits or marginal revenue, marginal cost is going to allow us to look ahead. It helps us to decide what should we do now and what should we do in the very near future. So technically speaking, the first derivative, C prime of X, gives the slope of the tangent line at any point x, which tells you the direction that the function is moving in at that point, right? It's the direction it's headed. The marginal cost, so this is actually more mathematical. here is the business. So this is the math part. And this is the business or economics. The marginal cost, MC with a bar over it, which I believe is fairly universal, but again, let me know if you've seen other notations for it, estimates, now it's an estimate, the additional amount it would cost to produce one more unit at the current level of production, which even when I'm telling this to people in person, they just hear blah, 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 blah. So what the heck does it mean? Well, if you understood this, then you know. But for those of you who just heard me say blah, 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 which I totally understand, let's talk about it. So, C of 100. Okay, so cost, let's see. I didn't give myself a place to write this in. I'm going to write it right here. C of x is 300 plus 12x plus 3x squared. So C of 100 is 300 plus 12 times 100 plus 3 times 100 squared. I'm going to need my handy dandy calculator. And that's going to be 300 plus 12 times 100, or 1200, plus 3 times 100 squared, which gives me 31500, or in other words, $31,000. So, to be honest, I gave you a cost function which was motivated more by wanting to create this type of a function and less by actually going out in the world and finding this commodity. But you can tell if the first 100 units of this commodity are going to cost you $31,000 to produce, this is not an inexpensive commodity. These are not candy bars or burritos. This is something like a piece of electronics or part of a car or something. It's a larger or more expensive thing. Maybe it's a piece of jewelry. Who knows? We are not being specific here. So this is the, let's talk about this. This is the total cost to produce 100 units. Okay? So that is the cost to produce number 1, number 2, number 3, number 4, all the way up to 100. The whole bunch of them is going to cost that. So now, C of 101, and I know we've all done this before, but bear with me. 300 plus 12 times 101 plus 3 times 101 squared. Let's take a look. Clear, clear, clear. 300 plus. This is the moment where I wish this were a class where I had access to giving you all 101 squared, to give you all graphing calculators, because this all becomes so much easier with the graphing calculator. And I get 32,115. So this is in, we were told this is in dollars. So this is the total cost to produce 101 items. Okay, now it asks us to take the difference between these two. So this will be 32,115 minus 31,500, which I'm going to say is like 615, but I never trust myself. So minus 31,500 gives me 615. So what the heck does this represent? It's a good question. What does it represent? Well, it's in dollars because cost is in dollars. This is the cost to produce, and I should write exact, the exact, not the approximate. This is the exact cost to produce the 101st unit. Okay, so here, this is the total cost of all of the units. 3, 4, 5, 57, 86, 93, 100, right? This is the cost for all of them. This is just that one unit. I'm not sure what I was going with that, but let me get rid of that little dot so it doesn't confuse me. Or not. Ugh. I'm gonna have talk to with this thing. It's not, maybe it needs a vacation or something. It's having some trouble. Okay, so let's take a look. This is the total cost to produce 100 units. This is the total cost to produce 101 units. So if you take the total cost to produce 101 units, you subtract out the first 100, this gives us just the 101st unit. And it's exactly 615. And I'm going to say it wasn't hard work, but this is just a lot of busy work. And this isn't too bad because I picked a function that's not too bad. But if you could imagine, and I'm sure some of you can imagine, there are some nasty functions out there, right? With square roots in them or weird exponents and fractional things, rational expression. It could get, pardon me, nasty really, really fast. So this, I'm going to try to convince you this is a lot of work. The next question I would like you to answer is, and let me remind you, C of x was equal to, where is it? Let me make sure I've got this. 300 plus 12x plus 3x squared. And the first derivative is 12 plus 6x. So let's review a couple things. One thing, I know you can see what the next page is going to be. No spoilers, no spoilers. So the original function is a quadratic, right? It's a trinomial. It ends in x squared. We could actually write the other way around. The first derivative is linear. That means it just has an x, does not have an x squared. This is a much simpler function. Just keep that in mind. So let's find C prime of 100. So in other words, the first derivative at 100 is 12 plus 6 times 100, which is 12 plus 600. I can do this in my head. This is 612. What is this? This is an estimate Now remember, derivatives are about forecasting. So this will give us an estimate for the cost of the next unit. So in other words, the 101st unit. Now, what was our actual cost? Our actual cost from the previous page was $615. Our estimate was right here. And over here, I'll put this in green so if you're following along with the color coding, the 615 came from previous page. Are we close? And the answer is, well, it depends on what your definition of close is, right? $3 off could be a lot or it could be very little. I would claim that given the scale of the number that we're talking about, $600, $3 is a very small difference. It's certainly less than 0.5% off. So this is a very close estimate. And then again, in terms of when we talk about cost, one of the problems with forecasting is that data is expensive. Calculations are expensive. Hiring people who can do calculations is expensive. Hopefully that's you guys. If that's what you're looking forward to, you're going into that job. They will be hiring you and paying very well for your services. So my question for you is, in the grand scheme of things, would you rather do all of this to get the exact value? Or would you rather do this quick and dirty, which literally you could do in your head or on a napkin? A lot of people in economics love doing math on napkins when they're out to fancy dinners. It's a big thing. You could do this in your head and have an estimate like that and not have to go through all the work. Could you do the work? Yes, you could. You now know how to. You've known how to for a couple chapters now. But this is an estimate, and it gives us a way to approximate what's happening next. And how would you use this? Well, what if you also knew the marginal revenue? The marginal revenue would be the revenue that you'd get for the next unit. So the 101st revenue, then you would also know your marginal profit. And that would help you predict. If someone comes to you and says, should we increase production, you could give them an informed answer. Okay, the next one we want to do, the first derivative at 200, which I know, where did 200 come from? Stick with me here. I'm going to do 12 plus 6 times 200. And that's going to give me 12 plus 1200, which is 1212, which is very cool, unless I've made a terrible mistake. Oh my goodness. You know what? I make too many mistakes. So let me give that a try. Plus 12. Yep, it's 1212. Okay. So what does this mean? This is an estimate. Whenever you're talking about derivatives, you're always a little bit off, usually a little bit off. I won't say you're always a little bit off, but derivatives, they're an estimation tool. So it's an estimate of the cost to produce what? The 200, the very next one, right? It's forecasting, so you go to the next one, next unit. So that means it's the 201st unit. Okay, kind of woohoo, kind of a little bit. So what does that mean about your production costs? Something really weird is happening, and partly I gave you a weird, that's a weird formula for cost, but I thought it would be fun to play with, and it would give us very extreme answers that we could talk about. So what's going on here? Well, it turns out that whatever we're doing is very expensive, and my guess is that we're running out of materials, or we're going to have to do something to increase production, right? The 101st unit will cost us just over $600. If we want to make 200 of these, our costs are going to go over $1,000 each. So again, maybe this is, if you're thinking of technology, something in you're trying to make little chips, and these chips are just amazing, but they use this really fancy metal that's only found in one place on the earth, and it's very rare. Or you're needing to, in order to increase production, you need to build a new building, make a brand new, factory to build these. Something is going to happen that will send your costs north. And how is this useful again? Well, we can see that this is the marginal cost at 100. This is the marginal cost at 200. The marginal cost itself is increasing. So the instantaneous rate of change of the cost, the marginal cost, is increasing. I know I didn't put this in. This will be E.2. What's the second derivative? If the first derivative is 12 plus 6x, the second derivative is 6. This is positive. So it means it's increasing, it's going up, right? The slope is positive, it's going up. So what does that mean? That means that the marginal cost is increasing. So in other words, the cost to produce another unit is going up. The more you make, the even more you're going to have to spend. So this is a complicated decision. You're going to have to figure out at what point do you want to stop making these. And you've got a couple considerations. One consideration is what revenue is coming in. Like if you are Apple, you might be making things that are very expensive and you're not selling a lot of them, but you're selling them for a lot of money. And so it may be that the profit motive is great. If the cost is $1,200, but your marginal revenue at this point is $3,000, you could be making a lot of money, so you'd keep doing it. What would be another reason why you would keep producing? You would increase your output. Well, it could be that you're trying to take over the market. You're trying to sell the most things to put your competitors out of business. So it may be expensive to produce more of these things, but maybe it's worth it. You're willing to either make less money or even take a loss so that you can convince all the customers to come over to your brand, your company. So a couple things that you could talk about, and you'll talk about more in your business classes, and it's super fun. Does the cost per unit increase or decrease as the production increases? As production increases, so production is X, from 100 to 200 units. The marginal cost, which is the cost per unit for the next unit produced, increases from 612 to, oh, sorry, you can't see that. Here I'm writing and you can't even see it. As production, which is X, increases from 100 to 200 units, the marginal cost, this is the cost per unit for the next unit produced, increases from $612 to $1,212. And these are approximations for the cost per unit. So the cost per unit increases. Woo. So there's one set of things that, believe it or not, we've been talking about the whole time, but just I wanted to put it in one place for you. Then we're going to shift gears completely and talk about maximum profit. This is another application of derivatives. So if we look at a parabola that opens downward, there we go. We see that the vertex, remember the vertex is that point right in the middle. Remember there's an axis of symmetry. Here's the vertex. And I claim, if you take a look at this value right here, if this were the y-axis and this were the, sorry, I should be using a ruler. I did not. But if this were the y-axis right here, that's the maximum y value right there, right? That's the very highest point that we get to right there, whatever that value is. And so my question for you is, what is the slope of the derivative at that point? So in other words, oh, you know what? Oh, typo. My goodness. That doesn't make any sense. What is the slope of the, what is the word that I should have used? I used derivative. It should say, you're right, tangent. Sometimes I write these out and then I realize I'm switching words around. What is the slope of the tangent at that point? So at this point, what does the tangent line look like? And remember, the tangent lines are the lines that if I had my ruler, which is over here, that's the point. We look at the point and then we try to balance a line that kind of just skims the function at that point. All right, so we could have that one right there And this one right here would be, they're kind of hard to draw with a pen because something like that. So what would the tangent line look like right there? Would you believe me if I said it sits just like this? So what's happening here with this function? Let's take a look. In the parabola, I would claim that as we move along, the tangents look like this. They go like this, they flatten out, oops, and then they come, oops, like this, like that, and like that. So in other words, over here, where the function is increasing, the tangent lines are facing up. Over here, where the costs are decreasing, or I'm sorry, profit, then we're talking about profits now, the profits are decreasing, the tangent looks like that. And right here in the middle, the tangent line is perfectly flat. And then the next question is, what's the slope? And the slope of a horizontal line is 0. It's not increasing, it's not decreasing. So here the slope is positive. Here the slope is negative. So these are going up, 0, down, right? Up, down, and this one's sitting right in the middle. So the slope is 0. Okay, so it turns out one of the easiest ways to find the maximum point in a function is simply to take the derivative and set it equal to 0. Just like that. Okay, so next question. I know that was a big page with not a lot going on. I just wanted to draw a couple of graphs. The price of a product in a competitive market is $200. If the cost per unit of producing the product is oops. Oh my goodness, my hands sense that it's almost the weekend. They're like, let's go to the beach. I'm like, no, because there are seagulls there that will try to steal our calculus. 150 plus $0.1. Oh, sorry, there's the X, left off the X. Where X is the number of units produced per month, how many units should the firm produce and sell to maximize its profit? Woohoo! We are circling back to the very beginning. I don't know if you all remember the very beginning of this class, but in the very beginning, we started talking about profit, revenue, and cost. Specifically, that profit equals revenue minus cost. Okay, so we're going to need to find revenue. Remember what revenue is? I know, it's like, oh, really? We still have to know that? The answer is yeah. But this is a good review for the final, if nothing else. Remember, it's price times output, which is 200x. So far, so good. Now, cost equals... Now, this is different. If the cost per unit is this, then the total cost will be the cost per unit times the number of units, right? There's a slightly different way. I know back in the beginning we did fixed costs and variable costs. This is slightly different. This is cost per unit of producing the product is this. So it's all wrapped up together. And that's going to be 150 plus 0.1x times x, because x is the number of units produced. That's our production. Okay, so far so good. My profit is going to be my revenue minus my cost, which is going to be 200x minus 150 plus 0.1x times x. So far, so good. Okay. So this is kind of cool. You can create all of this. So all they're telling you is they're telling you these two pieces of information, and then you just go to town. And with everything you've learned this semester, you can pull all this together. You guys are brilliant and amazing. Look at all this stuff you know about the world. Okay, so this is going to be 200x minus 150x, right? Minus 0.1x squared. So I've got 50x minus 0.1x squared. Okay, I go back up and I double check, is there a fixed cost? And it says no, we're not going to worry about fixed costs. So this is it. This is all we have to worry about. Okay, so I want to maximize the profit. So I'm going to take the first derivative and set it equal to 0. So in this case, we can see that profit is actually just a parabola, and it is a parabola that opens downwards. So if we find the place where the tangent line is flat, where the slope is 0, then we find the maximum. Now, something interesting, you could also find a minimum. Think about if the parabola were facing upward, if it opened upward, you'd find the bottom point. So obviously there's going to be some more details about this, and we will get into this. There's a little bit we talk about in chapter 10. So for right now, we're just going to set it equal to 0 and see what happens. So first derivative, 50x, the first derivative is going to become 50. And then I've got minus 0.1, and then I've got 2x, right? The 2 comes down. So I get 50 minus 0.2x, and I want to set that equal to 0. And I clearly will need another piece of paper. So let me rewrite this. 50 minus 0.2x equals 0. Okay, 50, that's what we've got right there. So then I'm going to add 0.2x, and I'm going to add 0.2x. You could subtract 50, however you want to do it. This is a matter of style. You actually don't have to do this. I know a lot of people could probably solve this problem in their head. You can divide both sides by 0.2. You can multiply by 10. You can multiply by 5. Why can you multiply by 5? I like that one. Let's look at that one. I know people are going to look at the notes and be like, what the heck? Why would I multiply both sides by 5? Can you see why I would do that? You've got lots of options. You're allowed to do whatever you want to both sides, except multiply by 0. So what happens? Over here I get 250. What is 5 times 0.2? It's 1. So I just get x. Isn't that cool? So if you want to divide both sides by 0.2, you'll get the same answer. Okay, so x equals 250 units. What the heck does that mean? Let's take a look over here. We were trying to maximize the profit. So the derivative of p at 250 is 0. So that means that that point that's right at the top there, where the slope of the tangent equals 0, right here, this is x equals 250. That's what that means. So if you want to maximize profit, which you might not want to do, but you could, to maximize profit, produce 250 units. How many units should the firm produce and sell to maximize its profit? To maximize profit, produce, and I should say and sell, because that's part of it, 250 units, and that's it. I've run out of ink. but I've also run out of chapter 9. So life is good. We're also running out of video. This is so exciting. Are you guys excited? There's the last page if you want to take a look at it. The notes will be up as soon as I can get them up. I hope you guys have an amazing weekend. Whatever day you're watching this on, I hope you have a great day. I'm very excited. We've gotten through chapter 9, and that's really amazing. Again, hold yourselves gently. Calculus is not easy at first. It can be very frustrating for a lot of folks. And again, I'm starting to sound like a broken record, but I took calculus 3 times before it really sunk in. So, you know, if it's making any sense right now, nicely done. And hold yourselves, ooh, this is hard to do. There we go. Hold yourselves gently. This is not easy stuff. Take care, be gentle, you know, eat some